Hello everybody, hopefully you are doing well, fine. We'll continue with lesson 4 of chapter 12, heat. We finished part 1, this is part 2. So as you know that we learned in the first part of this lesson about heat, about conduction, convection, and radiation. Today we're going to talk more about heat. So you know that buildings are heated by systems designed to transfer heat energy. In a hot water watering system, water is used to transfer energy from a boiler, which is forced through pipes by pumps. The pipe leads to convectors in the room, and the air around the convectors become warmer. Now, the convection currents circulate air through the room, and the room is warmed. Now, as the air, heated air is less dense than the cooler air, so it rises in the room, and as it cools, it sinks back down, and it's eventually heated again. On the other hand, in a forced air heating system, a room is heated with air alone. Hot air forced up by fans from the furnace, where the heat air heats the air in the room. Convection currents then circulate the air in the room. Now, both the boilers and furnaces, they operate all the time, and buildings would soon become too warm. And we could use more fuel than necessary, or you can use overused things. So therefore, heating system have a way to turn on and off automatically. A thermostat switch controls this process. The switch in a thermostat is often a bimetallic strip, as you can see here. Now, this switch actually is made of two different kind of metals. Different materials expand or contract as the air on their own particular rates. Different materials have different expanding rate or contracting rate. So when the bimetallic thermostat strip is heated, one of the metal expands more than the other. This expression causes the strip to bend, and when it bends, this bending of this strip turns the system off when the air in the room reaches at a certain temperature. So this is the work of thermostat, basically controlling that heat. Now, you might have seen, or all of you have been through cars. It's quite normal here. Now, but have you ever thought how the engine of the car works? You know that we use gasoline, petrol as a fuel that is burned in the engine of a car, but actually it's the heat energy which actually makes the engine move. Heat causes the gases from burning fuel to expand. These gases push on pistons. These are pistons inside the engine, which then move downward, and the motion of these pistons triggers a chain of action that turns the crankshaft. This is the crankshaft, and propels the vehicle forward. This is inside the engine. So the pistons, they move downward. The motion of piston triggers this chain of action that turns this crankshaft and propels the vehicle forward. You know that we use coolant in the engine's radiator, which is a liquid, to keep preventing the overheating of the car engine. Now, as the car moves along a road, there's friction between the tires and the road. Friction produces heat. If enough heat flows into the material of the road may expand. So on hot sunny days, radiation also causes the temperature of the road to rise and thermal expansion to occur. Now this expansion could cause a roadway to buckle or bend. That's why joints are used. If you have seen in different places, they use joints in the roads and bridges to make sure the roads do not bend like this. To prevent this kind of damage, separators or joints are placed between sections of road. They're made of materials that are good conductors. Now these sections expand and contract as the road warms and cools to help protect the road from damage. Now here we have the how heat propels a car. We have the intake stroke, then the compression stroke, power stroke, and exhaust stroke. Here you can see that there is low pressure in the cylinder, okay, which pulls the mixture of air and gasoline vapor through the open valve. All right, now the piston, if you see here, is moving down, right, causing as the piston is moving down, you can see that it causes the pressure in the cylinder. Then you have the compression stroke. In the compression stroke, you see the intake valve is closed, right? Now the piston moves up. Here you see the piston was moving down, so the piston here is moving up and compresses the fuel and air. In the third part, you have the power stroke. The power stroke, the spark plug, you can see it ignites or lightens the fuel. Then the hot gases expands and pushes the piston again down. Now the moving of piston actually turns the crankshaft, which propels the car ahead, and your car moves ahead. While the exhaust stroke, and the exhaust valve opens, the piston moves up and pushes the burned gases out of the cylinder if there is any exhaustion or any heat, extra heat there. Now coming to temperature, you know, temperature is a measure of the average kinetic energy of a substance molecule. Thermometers measure temperature. Some thermometers are made up of clear tube containing a liquid that expands when it warms, such as you have the normal classical mercury temperature. Some of them are digital. There's the one that you can see here. So there are different kind of instruments to measure temperature. So specific heat. Now physical properties such as shape, size, color, and texture vary depending on the type of matter. Another physical property of matter is the rate at which the substance warms up upon absorbing heat. So the specific heat of a substance actually is the amount of energy, often measured in joules, needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. How much? The amount of heat needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. This is specific heat. Most metals have a low specific heat, so little energy is needed to increase their temperature. Water has a high specific heat, so more energy is needed to raise the temperature. That is why you can burn your finger by touching the metal handle of a pot when the stove is on and when the water in the pot is lukewarm. So you can burn your finger because the metal can heat up more faster than the water. The water is not that much hot inside, you can touch it, but the metal outside, its specific heat is less. It takes less time to heat up. So the metal can burn your hand, but the water inside, since it takes a long time, its specific heat, it has different rate. For example, you see here aluminium 0.90, you have copper, iron, and you see the water is 4.19. That's why water takes more time to heat up than these metals. So that was the lesson. We end up and finish this lesson here. You're supposed to solve your workbook and send it on Pioneer as attachment. Thank you.